So today we're going to talk about how to create desktop applications using web technologies. And when we say web technologies, we mean HTML, CSS, and JavaScript. More specifically, we will see how to integrate two awesome JavaScript frameworks, Angular and Electron, to create an awesome desktop application. So let me tell you some things about me. I co-organize an Angular meetup here in Greece, in Athens, which is called Angular Athens Meetup. And I work as a front-end web developer at a company called Plex-Earth, where I'm mostly specialized in the Angular development. Also, I work as a contractor at a private education institute called GitHub, where we teach developers and other individuals about the Angular framework. I'm an active contributor at the GitHub community. My two main areas of interest are Angular-based libraries and repositories, and libraries that are concerned with 3D mapping and geospatial libraries. When I'm not coding, I maintain my own blog at Medium, where I almost always write about Angular. And this month also, I wrote my first book about Angular, which was published from Pact Publications. It is now available to pre-order from Amazon and from Pact Publications. It is a book that is for beginners in the Angular framework, and it teaches you how to create an Angular application from scratch and deploy it to a hosting provider. It takes you through all the steps from scaffolding the Angular application up to deploying to a hosting provider. So if you're now making your first steps in Angular, I would definitely recommend it. I have put the slides. I have put some links in the slides so you can check it out. Now, as I told you, I work as a front-end web developer at Plex-Earth. Now, Plex-Earth is the main product of a company called Plexscape. Plex-Earth is the first hybrid desktop cloud-based platform ever created for the architecture, engineering, and construction industry. It cooperates with all the known CAD software, and for those that don't know, a CAD software is a software that an architect or a civil engineer uses to design 3D buildings and stuff like that, houses, cars, you know, all this construction and engineering stuff. So Plex-Earth can cooperate with all the well-known CAD software. One of them is the AutoCAD application, which is created from Autodesk, and you can see in this image how it looks like inside the AutoCAD software. Now, Plex-Earth enables actually architects and engineers to visualize their 3D models and projects in the real world. For example, someone that builds a house can use Plex-Earth to visualize it, how it will look like in the Google Earth or some other map provider. So, one of the main features of Plex-Earth is that it can import satellite images inside a CAD software. There are three ways to accomplish this task. The first one is using some satellite image providers, which we call them core providers, such as Digital Globe and Hexagon. Now, these providers have their own satellites or small airplanes that they use to take their own satellite images. The first way is using an intermediate provider such as Google Maps or Bing Maps. Now, these intermediate providers does not usually have their own satellite images, satellites, but they use the core providers above to buy satellite images from them. And the third and the final way to import satellite images into a CAD software is using a proprietary custom software that we have created at Plex-Earth, which is called Map Explorer. Now, Map Explorer is an application that is built with Angular and Electron, and for the user interface, we have used Angular material. We use Angular for the front end, Angular and Angular material for the front end development, and Electron for the backend. We will see more details about how we use it later on. Now, I will show you a video to better understand how we use Map Explorer inside Plex-Earth to import images into AutoCAD software. Before I begin, I would like to explain some things about how we visualize a map inside Plex-Earth. Now, we can think of a map as a set of different layers. For example, if you would like to create a map that displays different background color for each state of the United States of America, we would create a map that consists of 3 layers. On the bottom, we would put a Google Maps or a Bing Maps layer. Now, the bottom layer is called base layer, and it takes all the globe, all the area, all the world. On top of that, we would put a layer that displays only the United States of America with their borders. And on top of that, we would put another layer that displays each state with a different background color. So you can think of it as when we put slides, when we overlay slides in a projector to display something on a remote screen. So let me show you now the video that we have created for this presentation. Now, in this video, we will see how we use Map Explorer and Plex-Earth to import images, satellite images, inside AutoCAD. Here, we are currently in the AutoCAD environment, and we use Plex-Earth to open Map Explorer. Now, you can see Map Explorer, it has opened. It is an Angular and an Electron application. The user interface is created with the Angular material. So we have already created our base layer at the bottom, which is called OpenStreetMaps. And we are now placing another layer on top of that, which is called ESRI map. ESRI is a very well-known satellite provider. On top of that, we will create our real layer, the final layer, that will display the railway network of a city. Now, sorry about the name, which is in Greek. It says railway network. So the Map Explorer application that you see is a totally different application, a totally different executable that is loaded on demand from the Plex-Earth application. Now you can see here that the railway network is our blue lines. We can toggle the visibility of some layers to show how it is, to show the different layers. Now we close Map Explorer, we select the area in AutoCAD that we want to import the map. And Map Plex-Earth now will start the process of downloading the map that we have just created inside the AutoCAD project. So here it is, the map that we have created using Map Explorer. It has been imported inside AutoCAD. Let me switch back to the slides. So what we will see today, we will see how, here you saw how we use an Angular and an Electron application to import satellite images inside an external application, such as Plex-Earth. So we will see later a demo application that will mimic some of the techniques that we use in Map Explorer. Now, As I told you, Map Explorer is an Angular and an Electron application. I think some of us we already know about Angular. So let's see what is Electron. Electron is a cross-platform JavaScript framework that allows you to create desktop applications using web technologies, HTML, CSS, and JavaScript. Its main advantage is that you can leverage your existing skills if you are a web developer to create desktop applications without the need of learning a new language, a new desktop language, such as C++ or C#. Electron is an NPM package, so we can install it using the standard npm install command from the npm registry. As you can see here, we install it in the development dependencies of our project because Electron is not used runtime when our application runs, but only when we want to build our application. Electron is built on top of Chromium, Node.js, and V8 engine of Chrome. And actually, an Electron application contains an embedded version of Node.js and Chromium. And that is the reason that all Electron applications are very large in size. Imagine that Map Explorer that I showed you before is about 97 megabytes, and 3 megabytes are only 3 megabytes are our application assets. The remaining 94 megabytes are the runtime, the Electron runtime. So you can see that there is a potential drawback in this for Electron. Now, many applications use Electron. Many of us have already used Visual Studio Code. This is an Electron application, Slack, WhatsApp, or Skype. In the website of the Electron, you can find an extensive list of which applications are written using Electron. And believe me that there are some applications that you don't even imagine that they're written using Electron. Let's talk a bit about the architecture of Electron. Electron is comprised of two processes. The main process, which is responsible for the heavy-duty tasks and calculations, for example, when you want to interact with the file system of your computer, and it is a process that provides access to native resources of your computer using Node.js API. And there is also the renderer process that is responsible for managing the user interface of the application. You can think of it as a single index.html file that contains your application assets. Now, in our case, in Map Explorer, the main process is the Electron side, and the renderer process takes care of the Angular side. Electron follows the Chromium multiprocess architecture. So at an Electron application, you will only see one main process. On the contrary, this main process can communicate with different renderer processes. Each renderer process operates in complete isolation. If we want to communicate from one process, from one renderer to another, we would go through the main process. There's a way to communicate directly from one renderer to the other, but this discards. We should only go through the main process. Now, how could we create an Electron application? An Electron application mainly is a JavaScript file, or if you write in TypeScript, is a TypeScript file, a main.ts, just like Angular has its own main.ts. Excuse me for a moment. Now, first, this is the code that we write, the minimal code that we write to create an Electron application. We use the Electron npm package to import two artifacts. The first one is the app, which is the application window. For example, you can think of it as the window object, the global window object of a browser, of a page. And then we import the browser window, which is the actual window inside the app object. So to create a window, we use the browser window class to instantiate a new object, and we pass some parameters. These parameters, there are a lot of it. If you check in the Angular website, you will see a lot of it, a ton. Some of the most common are the width and the height that defines the width and the height of the desktop window. Then we use the load file method and we pass an HTML file that we want to load inside this browser window. Now, notice that in our case, this HTML file is the main HTML file of the Angular application. We will see later details about that. So, here, we create a promise in the app object, and we say essentially that when the application is ready, when the app object is ready, and the promise is resolved, then you can create the window, because we want to make sure that we want to make sure that the app object, the app global object, will be ready before creating the window. Now, I know for sure that you can create multiple windows for each app object. I haven't done it myself, but I know that it is possible. So, there are some considerations that you may encounter when you're developing an Angular and an Electron application. There are some of them, we met some of them during building Map Explorer. So, Map Explorer was always a part of Plex-Earth. It was embedded inside Plex-Earth, but then at some point we decided to rewrite it from scratch and use Angular and Electron, as you saw before. So, why did we do that? There are cases that you may want to have the same code base for different users and environments. For example, in our case, we wanted the civil engineer to be able to sit in front of its office and use the desktop version of Map Explorer that you saw in the video to import a map inside AutoCAD. Now, this map would have been created by a different user, for example, an administrator, that had access in a web interface of Map Explorer. But there may be two different modes of the application, but the code base would be the same. Another consideration is when you want to interact with the file system. In our case, Map Explorer is more than a desktop app. It is also our backend, and that is why we say that our application is something like serverless, because all user data are held in the file system in a JSON format. We don't have a backend API, we don't have any remote server. And the third consideration that you may encounter during development is how you can communicate with an Electron application. For example, in our case, we have Plex-Earth, which is an executable, and we have also Map Explorer, which is a different executable. So, you know, there is no easy way to communicate the two executables between each other. So, Another consideration when using an Electron application, when developing an Electron application, is how to communicate between the two processes, between the main and the renderer. Now, there is an object which is called remote object, which is used from the main process. The main process exposes this remote object, and it can attach some global variables on it. For example, in this scenario, we have attached in the global window, in the global object, the FS library. The FS library is a Node.js library for interacting with the file system. Now, in the render process, we could import the Electron object, get the remote object, and from there, we can use the get global method to get this global variable that the main process has exposed, has attached. Okay, so in this case, we're essentially exposing our file system, our FS library, into the render process. Now, the render process, remember that it is a web page. So essentially, we're exposing our file system in a web page. Now, this is not secure. I mean, we all know that it is very dangerous if we give access from a web page to our file system. So we shouldn't do that. We shouldn't use the remote object. For those that use already the remote object, if any of you use Electron and use the remote object, I have some good news for you. There is a switch inside the web preferences object of the browser window, which is called enable remote module, which you can set to false so that you can disable the remote object. Now, if you set this property to false, even if the main process has exposed some native APIs in the render process, the render process will not be able to use them. Now, in the latest version of Electron 10, this enable remote module flag is false by default. Generally, an Electron application has the same security problems as a web application, because at the end of the day, Electron is a web application. It loads HTML files and JavaScript and stuff like that. So whatever security problems have the web page, the Electron application has the same. So if you want to learn more about how to secure your Electron application, you can check my guest talk that I made in the Real Talk JavaScript podcast, that I discussed specifically about security considerations in an Electron application. So, what should we do then if we can't use the remote object? There is a method which is called IPC communication. IPC communication is a technique for exchanging messages from the main process to the render and back asynchronously. Remember that the remote object technique was synchronously, so this one is asynchronously. For example, how would we use the IPC? The main process would use the IPC main object that it can import from the Electron application, from the Electron module. Now, this IPC main object has a method called handle, which behaves similarly to an event listener. When we add an event listener, so handle. When we say handle, we can say that we add an event listener. The first parameter is the name of the event, get data, and the second parameter is an arrow function that will be executed when someone calls this get data event. Now, in the render process, we use a similar object with the IPC main, which is called IPC renderer, and we can use specifically the method invoke to call the event that we have just created above. In case we want to pass some arbitrary data to the main process, we can use the second parameter of the invoke method of the renderer. Now, please notice that here IPC communication is promise-based. So in the renderer process, we can use async await syntax. So let's jump to some code now. Let me switch to my code. So here it is. I have created a typical Angular application. using Angular CLI 10. You can see from the structure of the project that it is familiar. You know, to some of you it is familiar, but there are some additional files that we have created here. I use the CLI as I told you, and let's go straight away to run it. Now, usually in my daily routine as a front-end web developer, as an Angular developer, I use an extension, a VS Code extension, which is called NX Console. Now, this is has been created from the Narwhal team. They have done a great job, and it acts as a wrapper API over the Angular CLI commands. For example, it has many commands that are supported in Angular CLI. One of them is a serve command that we use it is the ng serve that we use in Angular CLI project. So if we click serve, we select the project that we want to run. We can pass some additional parameters if you want. In this case, we don't want to pass any, so I will click run to run the application. You can see that it calls ng-serve under the hood. The first time is always a bit slow for an Angular application. So let's open the browser to see how it looks like. If I go to localhost 4200, we can see that it looks like an Angular CLI application. I mean, the header and the colors are the same. I have used the same styles. I didn't touch any CSS. The main difference here is that we can see that it displays a list of pirate names. Now, pirate is my favorite thing because I'm a big fan of Assassin's Creed Black Flag, as you can see behind me. So our application contains only one component, the app component, that displays a list of pirate names. Now, let's see how we can convert this to an Electron application, to a desktop one. Let me kill my terminal. So, in the Solution Explorer, inside source folder, we have two folders that we need to pay attention. Sorry about that. The first one is the app folder, which is the ordinary app folder that we have in any Angular application. It contains Angular code inside. And we have also another folder, which is called Electron, which contains the Electron code. It is better to separate the two codes so that you can maintain them more easily. Inside, we can see the main.ts that we saw before. Sorry. Here is our create window method that creates the browser window and loads the index.html. And here we have the when ready promise that when resolved we create window. Now, pay attention to this one, index.html. This HTML is the main HTML file of the Angular application. So when we compile the main.ts into JavaScript, we will put it in the same path as the Angular code. So our solution will first build the Angular application. Now CLI will build and output our Angular application into the dist folder, and then we will transpile the main.ts of the Electron code and put it inside the same folder, so that this code can work as expected and doesn't have any problems with paths. So how do we do this? Let's first run it, and we will see again, we will see later how we do this magic. Now, inside the package.json, we have our start command, our start script, which is the ordinary ng-serve, and we have another one which is called start Electron. Now, what does it do? We run at the same time the ng-build command using an Electron environment that we have created. I will show you later what it contains, but we don't delete the output path, because in the same path, we will also build and output the Electron code. So the first step is that we build the Angular application, the Angular code. The second part is that we use Webpack, and we pass a custom Webpack configuration to transpile the main.ts file from Electron into JavaScript. So the two compilations take place together, and they both operate in watch mode, so that when we change something, the recompilation process starts again. So if I go to npm scripts and select start Electron, now you can see it starts first, it compiles our Electron application, which is here, the cell.js file, and then it will build the Angular application. Here it is. So how do we run the desktop application, the hybrid application? Because now it is a hybrid application. It contains the Angular code and the Electron code. Now, if we go to the dist folder here, we can see the we can see the files from Angular. One of them is the main.js. We can see the index.html file, and we can see also the cell.js file. This cell.js, together with the map, with the source map, is the Electron code. Now, please notice that we name it as cell.js so that there's no conflict with the main.js file of Angular. If we now go to the debug menu of Visual Studio Code here, I have created a debug debug launch configuration. So if I click start debugging, it will open up our application that we saw earlier, but inside the desktop window, as you can see here. Oops, sorry about that. Now, this application, our Angular application, which is located inside here, is rendered inside a Chromium window. And we can verify that if we go to View, Toggle Developer Tools, we can see that it is a normal Chromium window. It has the console, it has the network, the elements, we can inspect everything we can do with the web page. So what did we accomplish? We managed to run an Angular application with just a single line of code, the load file that we saw earlier, as an Electron application, as a desktop application, without touching even the Angular code. So let's see how we can do, how this magic happens. So if we go to the Angular application, we go to the app folder, okay, we can see that there are two services. Now, I must tell you at this point that the Angular application that you saw at the very beginning, it loaded the names of pirates from a JSON file inside assets. So what it did, it used the built-in Angular HTTP client to load the names. If we go to the pirate service, we can see that indeed it uses the HTTP client, and it contains a method getPirates that makes a get HTTP call to the pirates.json file, and please notice that it converts it to a promise using the toPromise ArcJS operator. Now the component inside ngOnInit, we call the getPirates method, and this getPirates method calls the getPirates of the pirate service. Now, please notice also that we use async await syntax. Okay, so when we run the application as an Angular application, we make an HTTP call. Now, in the case of Electron application, the desktop mode of our application, we don't make an HTTP call. We read the pirates.json file using the FS library from Node.js. So we have created another service, pirate local service, that it doesn't, you can see that it does not inject the HTTP client, it injects an Electron service. Now this Electron service is a service that we use from a library called ngx-electron. This library is a wrapper API over the Electron object. I could create my own wrapper, but I don't like boilerplate code. I don't want to reinvent the wheel, so I use this one. So it injects the Electron service and uses the IPC renderer object that we saw before and invokes the getPirates. Now this invoked method returns a promise that when resolved, it will contain the names of the string, the names of the pirates. Can we do this? If we go to the main.ts, we can see the event that we have registered using the IPC main object with the handle method. It is called getPirates, so they can be, it is crucial to be the same as the one that we use from the Angular. And we use the FS library to read the pirates.json file asynchronously and return it as a list of strings. So in this case, we don't make an HTTP call. We just read it from the file stream, from the file system. You can check this out if you download the repository. There is no HTTP call. So how our application knows if it works, how does it know if it needs to make an HTTP call or an IPC main call? If we go to the app module, we can see here in the providers array that we have created a provide object literal syntax, and it essentially says that when someone asks for the pirate service, when someone wants to inject it, use the pirate factory to decide which service you will serve. So the pirate factory injects both HTTP client and Electron service, and we have created an environment variable that is called desktop. When this desktop variable is false, we create the pirate service using the HTTP. When it is true, and it means that we are in the Electron world, we create the pirate local service and we pass the Electron dependency. So this is how the magic works, because if you notice in the package.json file, inside the scripts, here we pass the Electron configuration. Now this Electron configuration corresponds to the Electron environment that you will find inside the environments folder. Here it is. You can see that there is a property called desktop. For the Electron environment, this is true. For all other environments, it is false. Now, Bhaskar, if I don't have time, you can interrupt me, okay? I just want to say
sure.
5 minutes.
Yep, sure, go ahead.
Thanks. So, we saw how to run our desktop application using when we develop. What do we do when we want to build it for production? there is another script which is called build Electron. Now this one calls the ng-build method, passes the Electron environment, and it also passes some production related properties of the Angular CLI. Also, it compiles the Electron code, again using Webpack, but with a different configuration. This time we use the Webpack Electron prod configuration. You can see the two configurations on your Solution Explorer. I don't want to go too much in detail because we don't have time, but if you have any questions, let me know at the end of the show. So, if we run the ng-build, the build Electron, again, it goes through building the Angular application and the Electron code. Now, this is production build that we're making. So Angular finished, and now also Electron finished. If we go to the dist folder now, we can see that it contains a main dot, a main dot, a hash.js. This one is the Angular code, and this main.js now is the Electron code. We name it main.js now and not shell.js because now we will not have any problem with conflicts between the two files. So we build it as a production. We now need to package it as a desktop application, as an executable. We will go to the npm scripts. There is another script called package. Now this script uses a library called Electron Packager that allows you to package your application in different operating systems. It supports Linux, Windows, and Mac OS. And as far as I know, you can build from Mac OS for a Windows environment. So if we go now to the dist folder, we can see that there is the output application as before, but we also have another folder which is called Win32. This is the name is from the environment that I told him to build. If we open this in our file explorer, now here you can see the desktop application. This executable is the Electron runtime. If we show the properties, we can see that it is 105 megabytes, only the runtime of Electron. Now, in this executable, in this file, there is not our application code. Our application code resides inside resources, and it is this app.asr file. Asr is a file format for is a zip format for Electron applications. You can open it with any FTP client. Zip client. I'm sorry. As you can see, it is only 189 kilobytes. So our desktop application consists of the Electron runtime, which is 100 megabytes, and our application, which is 100 kilobytes. I mean, the difference is huge. So, to summarize, I will give you also a tip, and then I will finish my presentation. As I have already told to you, an Electron application uses Chromium. So, in this .browser list.rc, essentially, we could remove all content that is not related with Chromium, because we only need it for the Chromium. But in your case, you can extend this functionality and maintain two different browsers list RC files, one for the Angular web version and one for the desktop version. Now, so what we have achieved with this demo is that we can build an Angular application either in a web mode and host it in a web server, or in a desktop mode and package it as an Electron application. So let me switch to my slides. So at the last slide, I have put some communication links if you want to reach me. And I have put also the demo link, which is at my GitHub profile, and some other resources. Thanks very much for watching this talk. It was great. I hope you liked it, and it will make you start creating hybrid desktop applications from tomorrow. So thanks very much. It was my pleasure. Pascal.
Thank you. Thank you for giving us an overview with Electron and Angular Aristides. Did I spell correct?
Yes, but you can.
If you can't spell it, but you spelled it just right. It was
okay,
correct.
Right. So yeah, you were showing us the sizes of the application runtime and the actual app. So the app takes around 189 KB, and the Electron runtime takes the major chunk of the size. So you suggested us that we should make sure to update our browser list.rc file, so that will it reduce the size?
Actually not, because this browser's list that I show you, it is part of the Angular code.
Okay.
This file tells Angular which browsers wants to support. So it will polyfill some features. If, for example, if you need Internet Explorer 11, Angular will put some polyfills in your application to support Internet Explorer. Now this one is not related with the Electron code.
Okay.
The size of the Electron is so big because of the Node.js and the Chromium that there is inside the executable.
Right. Cool. So you suggested that
you can't do anything about that.
Yeah, you suggested that we can do a separate version for web and a separate version for desktop while you deploy. Okay.
Yeah, that's right. Yeah, because in a desktop mode, you don't want to support Firefox because you are in Chromium environment. But in a web mode, maybe your clients will access your web application using Firefox. So
right. Cool. So if we want to use this approach of combining Electron and Angular, so are you seeing any breaking changes with the latest version of Angular or latest version of Electron?
Actually, Electron now has taken some steps towards being more modern, because I think Electron version 8 didn't have promise-based APIs. It was plain callbacks. So in Electron 9, they introduced promise-based in their API. So this was a major breaking change. But when you want to make an application work with Electron Angular, you can let me say, you can develop it separately. For example, a team can develop the Angular part and another one the Electron. So any breaking changes will not interfere between them.
Right. Yeah. Thank you. Thank you again for speaking with us and going over the code. Thank you all for joining us on Twitch as well. If you have any questions, you can always reach out to Aristides and on Twitter, and you can get your questions clarified. Thank you all for joining today, and we hope to see you at our next meetup.
Thanks very much, Bhaskar.
Yeah,
Bhaskar, thanks. Bye.